Think all of you joined. So good morning to one and all. In the previous class, we have discussed about the digital instruments. We have discussed all the digital voltmeters, multimeters, Q meter, electronic counter, electronic energy meters, LED, LCD. We have discussed those things. So we have finished that one. And fifth unit, the last unit of the electrical measurement and instrumentation subject is called oscilloscope. Now that is called oscilloscopes. So today we are going to discuss, I think anyone have you heard the name of oscilloscopes? Yes, देख रहे क्या oscilloscope कोई? Is it audible or not? Is it audible? The screen is visible?
Yes, sir.
Okay. See, the physics lab, I think, no, I don't know. How many of you have visited the hospitals? ICU में रखा रहते उसका ऐसा वेवफॉर्म्स आया वाला रहते देखो उधर like this. मैंने मूवी में देखा होगा शायद. Yes or no?
Yes, sir.
कोई भी ICU में रहते उसको ऐसा वेवफॉर्म्स आया वाला रहते ना like this.
Yes, sir.
So that is the oscilloscope we are going to use. That is nothing but oscilloscope we are going to call that one. Just I am giving the उसका picture थोड़ा imagine करना चाहिए आपको. That's it. So again the oscilloscope different types are there, but for your syllabus only that is CRO is there. Cathode ray oscilloscope we are going to use. We are going to use one cathode ray, cathode tube we are going to use. That will produce the light. The phosphor material we are using that one, that is fluorescent. So that cathode rays, it is going to reflect in the form of voltage, current, whatever we are going to measure based on the time or frequency. With respect to time, we are going to measure that one. It is going to display over there. So based on its operation, again one more the device is there, that is called digital storage oscilloscope. We are going to call that one. Whatever in the hospital, we'll see that is oscilloscope, commonly we'll tell that one, but that is called DSO, digital storage oscilloscope. It is going to store the oxygen level, the breathing of the human beings and all the things. Okay, suppose anything happened, the supervisor or whatever the nurse was not observed that one, but we can rewind back and we can check that one. It is going to store in the memory. That is called DSO. We are going to call that. Okay. So just the oscilloscopes, the unit 6, the last unit we are going to discuss here in the today class. So this is the syllabus. First we are going to discuss about the introduction of the oscilloscope. That is nothing but CRO or whatever it may be, oscilloscope. Then we are going to discuss about the CRO, that is the cathode ray oscilloscope. We are going to call that one. It is the main heart of this instrument is the CRT, cathode ray tube is there. Okay, cathode ray tube we are going to discuss, that is the applications, features of CRT we are going to call it here now. Here the block diagram and each block operation, what is the operation of each block we are going to discuss in this one. And CRT features, what is the size, how much voltage is required, how much what is the advantage of that one, how the horizontal axis, vertical axis, these all things operating here. Now what is the operating voltage, supply voltage, these all the things, these are the features of the CRT we are going to discuss here now. So this is one part related to the CR. Another one is DSO, we are going to call that one, digital storage oscilloscope here. Digital storage oscilloscope, how we are going to use that one. So basics of digital storage oscilloscope, just they have mentioned only basic only, but I will detail about the working principle with the block diagram. I will explain about DSO. And DSO used for voltage measurement, current measurement, phase frequency, time measurement, and Liz also is there or not, I don't know. No, it is not there for your syllabus. Just a minute. Okay, this much it is there. Someone has one, just a minute, roll number 38. So how is the use of DSO for the voltage measurement, current measurement, phase measurement, frequency, time measurement? These all the things, all of you, how many of you were present for the practical of the last experiment? I don't know. Last experiment को present था क्या कोई? Experiment number 8. Yes.
Yes, sir.
So I have shown already the measurement of various parameters like voltage, frequency, time period using oscilloscope. That is the same thing already we have explained, and you have seen the value also, how I have varied. I have shown the live, the voltage, how we are going to measure, how it is going to display. If the data cable is connected, it is going to store in the memory. I have already explained these all the things here. You have done the perform the experiment also for this one. Not you performed, you have seen the live performance of the DSO operation here now. So the basics of this DSO is very important here now. It has two parts here now. This is one part, this is one part here now. It will take 1 hour to complete this one. It will take 1 hour to complete this one. If I continuously if will take this one, it will finish in 2 hours, maximum 3. Like that it is going to do here now. So because due to the online situation, everything is ready in the PPT, we'll do that one. But when we will start to offline session, it will take time to draw the diagram of CRO. 1 hour it will take. Half an hour at least it will take to draw the diagram only. So they have mentioned for 6 hours for this syllabus. Okay, we'll start the introduction part of the oscilloscope or CRO, that is called cathode ray oscilloscope. We are going to call this CRO is the basic one. It is a basic oscilloscope. Basic oscilloscope is cathode ray oscilloscope. You remember the long form of this CRO, cathode ray oscilloscope, and it display the time varying signal or waveforms here. Here the x-axis, horizontal axis, what it is going to do, it is a time is there here. With respect to time, whatever the value, the magnitude will changes with respect to time, like this, like this. It may be, it is going to measure that one. It is going to display that one here. It is going to display a time varying signal here now. जैसा time बढ़ रहा है इधर signal vary हो रहे. Yes.
स्लाइड चेंज नहीं करी.
Yes.
सिलेबस की स्लाइड दिख रही.
सिलेबस का स्लाइड देख रहे क्या? Just a minute. अभी देखो.
Yes, sir.
So mistakenly what I have done, made the slide show. For that reason it happened here. So with respect to time, what is the value? It is going to vary. Based on that, we are going to, this is the time we are going to consider. This is the time. With respect to time, some waveforms it is increasing up to 5 seconds, then decreases for next 5 seconds, increases for 5 seconds, like that. With respect to time, which is varying signal, display a time varying signal here now. With time it is going to vary here now. So this type of, it is going to show that one. Also it can show like this also. This is the time. If the time is there like this, then the value will be vary for like this. Like this also it can vary. So this one also, it is, it will help to measure the value of that particular time. We can measure that value also. Okay. Second one, a CRO, cathode ray oscilloscope, is an electronic instrument. It is an electronic instrument used for studying various electrical and electronic parameters, behaviors here. See, for all electronic instruments, the power supply is required. Yes. टीवी कंसिडर करो, आप एक टीवी कंसिडर करो, इट इज इलेक्ट्रिकल डिवाइस और इलेक्ट्रॉनिक्स डिवाइस? It's electron LED we are using means for that reason only. I don't know how many of you have know that one. Actually the basic branches are, that is previously the basic branches are first the civil was there first, then electrical, then mechanical. These are the three basic engineering branches we are going to call them. Basic branches, engineering branches here now. Electrical, then mechanical, it will come mech. I'll write here now. See here, the civil again nowadays based on the applications what they have considered, they have changed that one. Plumbing engineer, plumbing is different, not plumbing, that is the structural engineering, environmental science, like that. So many branches they have derived here. The civil is that step, but the electrical is separated into so many parts. I will tell that one. This all the main circuit branch is electrical only. Next, this is separated into double E, that is called electrical engineering, and ENTC or electrical and telecommunication. ENEC we are going to call. EI we are going to call electrical and instrumentation engineering. One branch is the EI. Then from this E and C, again the computer science is also separated from electrical only. CSC, the base core branch for this one, CSC, IT, these all are separated from electrical. Next, the mechanical is split into automobile engineering, plumbing engineering, like that. They have separated their branch based on the application and based on the requirement of the society over there. So for that reason, what I am telling here now, just a minute. Here, thus basically we are going to, CRO is a electronic instrument here now, electronic instrument used for studying electrical and electronic parameters, and its behavior we are going to use here now. We are determining, we are going to identify its behavior, and CRO is basically XY here now. If the X and Y is that here now, X and Y, two-dimensional plotter here now, two-dimensional plotter, which can plot an input signal versus another signal. It can plot like this input signal, and the output signal also it can plot like this. Like this also it can plot, or an input versus time here now, like this it can also plot here. Like this it can also plot here. A cathode ray oscilloscope, that is called CRO, is used to study waveforms, transients, time based on frequency, time based or frequency based analysis. We are going to use to study the waveform here now. From this waveform only we will understand that one. For one cycle, the time taken to complete one cycle, that is called time period, we are going to call here now. For one cycle is nothing but it is 5 and it is 2/5, we can consider that one. For a half cycle, that is called 0 to 180 degree, how much value is there, the magnitude, what is the angle we can measure here now, we can study that one. And if two waveforms are there, what is the phase difference we are going to call, this is phase and this is another phase, one phase to another phase, how much angle difference is there, it may be leading or it is a lagging, everything we can understand here now. To study the waveforms we can study. And transients also, transients means if the any waveform is there like this, so with respect to time it is going to vary, like this the transients will come, it is not purely sinusoidal and all things here. This one, what is the transients are there, from here to here some transients are present, those study also we can do here. And based on time, it is nothing but time we can measure, or based on the frequency analysis. So we know that one, we f equal to 1 by t only, f equal to 1 by t, that is time period we are going to call. Based on the time period we can consider, or based on the frequency also we can consider that one. Both are reciprocal to each other here. We are going to consider this one. This is the just basic or introduction of CRO here. Next, we'll go for the actual block diagram of CRO here. I think you have studied in the physics subject. Yes? Physics में था क्या नहीं ये? कोई रिप्लाई दे दो. Yes?
No, sir.
No. Here, this is the actually the circuit diagram or block diagram we have considered here now. कुछ समझ में आ रहा है क्या? देखा तो. So it is very difficult to remember all the things. So what I will do, first I will go for the application based. I will tell you here now. See here, the reverse engineering will come back here. Here the CRT is there, CRT tube is there, this part is there, this is the display here now. This is the display, and whatever this part is there, that is called cathode ray tube we are going to call it. This complete block is CRT here. This is the heart of CRO. Heart of CRO. So this operation of this CRO, mainly it is dependent on x-axis and y-axis. Yes or no? X-axis is horizontal, that is x-axis is horizontal, y-axis is vertical. Y-axis is vertical here. Heart of this one is CRT, and based on x-axis and y-axis, we have considered some vertical inputs we are going to take, horizontal input we are going to take. For the synchronization of that one, synchronization we are going to take. For the lower signal to higher signal or higher signal to lower signals, whatever it is, lower to high, that is called amplification is required for both x and y. So for the horizontal amplifier, vertical amplifier, like that we are going to use. So for the horizontal, what is that one? The signals will like that is what is that one? Sweep generation we are going to consider that one. That is sweep teeth generation also we can call that one. Like that, that amplifier is also required here now. So we have to set the position of that horizontal and vertical to providing some delay and all the things. So for that is in horizontal or delay position and vertical position we are going to call that one. Trigger circuit is required, so trigger is required here now. Like that, some blocks we have made here now. According to that, I'll start my explanation here now. See, here the display is there. See, the input we have provided directly to the blanking circuit here now. Here vertical input is provided here now. These two lines vertical input, and this one it is going to give the horizontal input. It is going to give here now. Vertical and horizontal inputs we are going to give here. Whatever the vertical input is there, it is going to take that one and it is going to amplify if the signal is low. Otherwise, direct vertical signal also we can provide to vertical position here. And from the horizontal position, here the horizontal direct is there, we can take directly, we can give to the horizontal position here now. And if it is amplifying, then we can amplify that one. Okay, here external trigger circuits we have used. Synchronization purpose we have used for the horizontal axis. Synchronizing amplifier we are using. So sawtooth sweep generator we have used here now. That is one block. These all things, what it will do, it has to, the switch we are going to use internal and external here. If the externally we are connecting, external input we are taking, then external it is going to use. If internally we are giving that sawtooth sweep and whatever the horizontal axis, then internal switch it is going to connect here. This part completely, whatever, I will just a minute. This part is there completely. That is the input part here now. It is the input part here now. Externally we are going to provide here now. So input part here now. This is input for the CRO. Next, whatever the operation is there, based on this, it is going to operate here now. It is going to operate. How? The vertical angle we have taken here now. From the vertical position, it will set its position, and for the horizontal position, it is going to set the horizontal position here now. It is going to set the x-axis and y-axis. The dot will be there. But to display that one, what is this one? Cathode ray tube we have to use here. Here the tube is there here now. Cathode ray. Cathode we have used here now. Here the heater we have used here now. The tube is there visible here. The light or we are going to call fluorescent lamp, we have used phosphor material, we have used for that one. Here the cathode, the wall we have used, the light will emits over there here. Is it visible or not? So this part only we have to concentrate mainly. This is the CRT here. Now, if the CRT, how it is going to operate based on that. Unmute here, can I? Yeah. So this is the heater, and here the cathode is there. The light it is going to emit through the cathode, which will connect it to the, here the grid is there, and the cathode tube is there here. Now this is cathode, and one more, that is focusing anode here. Now here we have used anode here. This is cathode, this is anode here. Now based on that, it is going to fix the position of X and Y here. Now X and Y we are going to use here. X and Y is visible or not? Diagram visible hai kya nahi?
Yes, sir. Yes.
Okay, so this one, based on by varying this resistance of this one, we can set the position of horizontal and vertical axis. Based on that, it is going to give the display. Just overall I am explaining here. Later we will discuss blockwise. I am going to explain that one. Blockwise will take that one and we will explain that one here. So alternately we have provided some Z input, we have provided for the alternating purposes. If anything is not operating for the Y axis, X axis, we can use this one here now for the alternating blanking input here. Now it is a blank only we are using here now. Just extra for the the backup purpose, we have provided one axis here now. Next one, this is the, it is going to give the whatever the input is there, according to that it is going to give the display value here now. The output it is going to display in the CR tube here now. It is going to display the value here now. But the light intensity, that one you have seen that one in the hospital and all the things. The waveforms are colorful. One is showing the heart rate, another showing the oxygen, like that, the blood pressure, like that it is going to give over there. It is colorful over there. Some dim light, highlight, that is dark, like that it is going to give here now. So that one we are going to set by using some variable resistance value for the DC supply here now. External one more supply, we have same supply, which in DC supply we are going to use. We can connect by battery supply or whatever it the conversion you can do that one here. So intensity, to increase the light intensity, we have to vary this value. To increase the focus of that, we have to, by varying this one, we can focus and non-focus. We can, suppose I want to consider only X-axis, I have to focus. We can focus that one here. Okay, astigmatism, I don't know this one actually. Where it went here now, this one. And focusing anode here. Now it is going to increase the voltage, operating voltage, for the reasoning of that, limiting the current and all the things. So based on that also we can set this one here now. So here one more they have provided for the optional, we can use that one for the internally. If anything is, this one is damaged, you can connect that one here now, like that here now. So this is just the basic or the overall operation of the CRO block diagram here now. So mainly the blockwise we'll discuss now. The first thing is that is called CRT. The main heart of this one is CRT only. The heart of thing is, it is CRT only. This CRT is nothing but cathode ray tube we are going to consider. What it is going to do, it is going to emit the electrons here. Now, whatever the currents or inputs are there, it is going to emit that electrons, which is going to strikes the phosphor screen, that is called internally fluorescent. We have considered that one here now. The phosphor screen internally to provide a visual display. Whatever I think I told you yesterday, you have observed the old TV or night. ओल्ड टीवी पीछे इतना बड़ा रहता है ना, उसमें एक लैंप प्रोवाइड किया वाला रहता है नीचे, वो लाइट के हिसाब से we are going to get the display of that one. Like that, here we are going to, whatever the electrons it is going to emit, that is going to strikes on the screen internally to provide the visual display. Means with light only it is going to provide, na? Without any light, whatever the lines it is going to visible here now, those are lights only. In the CRO, this is light only, na? These are the electrons or light visual display we are going to get here. So this CRT, it mainly consists of 4 parts. It is going to consist. First one, electron gun is there. This electron gun, it is going to produce the beam of electrons here. No, electron beam it is going to produce. That beam will be reflect or deflect on the vertical plates and horizontal plates. So it will set the vertical plates and horizontal plates. So based on that, it will set its position of vertical and horizontal. Then the fluorescent screen, it is going to deflect on that one vertically and horizontally, whatever the based on the position, it is going to deflect here now. See here, where it went. This is the CRT here now. CRT. This is the vertical position, sorry, horizontal position, and this is the vertical position. See here, both are joined or not, you can check here now. See here, it is joined here. Again, it is joined the vertical position. Here we are going to provide the the electron beam we are providing here now. The electronic gun, it is going to provide the electronic beam. That one deflect on the vertical and horizontal axis here now. So it will take the position, then that will reflect or deflect to the fluorescent screen here now. To the visualization, it is going to deflect over there. So that is the main function of the CRT here now. It mainly consists of 4 parts. Next is there, I think, operation. The electron beam here now, which is produced by the electron gun here now. So beam will be producers. That beam will deflect in both vertical and horizontal directions here. That beam is there, electron beams. It is going to deflect both in vertical and horizontal directions by a pair of vertical deflection plates and pair of horizontal deflecting plates respectively here now, which is going to deflect respectively both horizontal and vertical plates here. Finally, the deflected beam will appear as spot on the fluorescent screen here. It is going to appear on the spot here now. In the screen is there here now. In this screen, the spot, they are going to get that one here now. Somewhere that is vertical and axis, and by varying the knob of that one, we can set that one. We can internally, we can intersect that one here now. In this way, CRO will display the applied input signal on the screen here now. Screen of CRT here now. So CRT is also, that is the main heart of the CRO, we are going to call that one. So this is the main function. The CRO main function is CRT only. The main device is or block is CRT only. It is going to operate based on this here. So electron, how many parts are there? Mainly 4 parts are there. That is electron gun, vertical position plates and horizontal plates, and the display here. Phosphorus or display we are going to call here. Now these 4 are the main parts of the CRT here. Next one, we have used vertical amplifier. We have used here now. So to amplify the vertical signal, we are going to consider, that is vertical amplifier. So this is a wide band amplifier used to amplify signals in the vertical sections. What are the signals are there to amplify that one? We are going to use this one. And whatever the positioning is there, that is it delay time line, we are going to call that one. It provides some amount of delay to the signal. So already one waveform is there exists, so it will, we can provide some delay also here now, which is obtained at the output of vertical amplifier here now. For the vertical amplifier, we can provide some delay. For that reason, we have used one delay line here now. This delayed signal is then applied to vertical deflection plates of the CRT. First, we have to provide the delay, then that signal is applied to the CRT over there. Next one, time-based generator here now. See, this one, for the horizontal, we are going to call that one horizontal deflection. The sawtooth signals, we are going to call that one, like a T, it is going to display over there. I think, I don't know how many of you observed that one. In a signal, sawtooth जैसा ही रहते हैं, आपको देखा है क्या नहीं मालूम नहीं है. Like that, like that, like that, it is there. Sawtooth deflection we are going to call for the horizontal deflection. So that is time-based generator, we are going to call that one. Next, horizontal amplifier, it is going to amplify whatever the time sawtooth signals are there, which is deflected to the horizontal plates. Those sawtooth signals are amplified by using horizontal amplifiers here now. It amplifies the sawtooth signal and then connects it to the horizontal deflection plates of CRT here now. First it is going to amplify, then it is going to connect it to the CRT. So trigger circuit, it is going to use for the true false triggers the signals, that one here now. So this is used to convert the incoming signal into trigger pulses. Whatever the incoming signals are there, it is going to convert into triggering pulses so that input signal and the sweep frequency can be synchronized. So based on the frequency, it is going to trigger the input signals here now. Very nice. 23. I will not give attendance for roll number 23. So this trigger circuit produces triggering signals in order to synchronize both horizontal and vertical deflections. So it is going to give the triggering signals to synchronize here both horizontal and vertical axis. Suppose इधर horizontal vertical ऐसा हो जाएगा और horizontal ऐसा हो जाएगा, कुछ तो समझ में आते क्या इसको? Both are not synchronized, then what is the value? How you are going to identify that? So for that reason, the trigger circuit will help to synchronize or combine both horizontal and vertical deflections of electron beams are combined or synchronized by using a trigger circuit. Is it recording? Recording हो रहा है क्या नहीं?
Yes, sir. Yes, sir.
I'm not getting the option here. Recording बोल के नहीं दिख रहा इधर. ठीक है. The next one is last one, power supply we are going to call. So this power supply is required for the CR or not? Without power supply, it is going to run? No, that is electronic instrument. So all the electronic instruments, the power supply is required. Yes or no? Your mobile is an electronic instrument. उसको power supply नहीं है तो चलते क्या? Mobile operate हो जाएगा क्या?
No, sir.
Any electronic gadgets you consider without power supply, they are not going to operate at all. So the CRT is also electronic instrument here. No, so it requires the power supply, but for the higher voltages, all the electronic instruments are there. They will get affect that one. For that reason, mostly we will prefer for the negative high supply, high voltages. So negative high voltages means very low voltages. We are going to call that one. Okay, it produces both high and low voltages. It is going to produce the high voltages up to 400 volts to minus 1500 here. See here, 400 means it is plus, minus 1500 means 0 se down high. There is very low voltage. It is now very low voltage. We are going to provide that one. See, in a signal, just a minute, I will tell that the negative high voltage and positive low voltages are applied to CRT and other circuits respectively here. The positive voltage supply is from plus 300 to 400 volts. The negative high voltage is minus 1000 to 1500 volts. This is passed through a bleeder resistor at a few milliampere here. If the voltage is V equal to IR, we are going to call I equal to what? I equal to
V by R.
V by R. If voltage is very high, then the resistance is less, then we will get the high current here now. So
Yes,
for
sir.
that reason, if it is minus, then the current will get very less value we are going to get here. So for the protection purpose also we can call that one. We will tell that one. See here, why you can think that why they are considering a minus, positive, plus and negative supply. See, you consider the sinusoidal circuit. It is going to produce only positive voltage only, like this it is going to produce. That is positive here now. If I want both positive and negative here now, then we can consider like this. Yes or no? What it indicates? It is positive. It indicates negative or not? Yes or no? See here, this is x-axis, this is y-axis, this is plus side, and in the here the 0 is there. So opposite to that one, it will become
Negative.
minus side here now. This is also y-axis only. This is x-axis minus side here now. So the waveforms are starting like this, means both positive and negative is required here. Yes, this is positive.
Yes, sir.
This is negative here now. For that reason, the positive and negative supplies are required. But for the by using the negative supply, we have some advantages of that one. So those advantages of using the negative power supply. Why we have to use the negative supply here now? So that is called, it is going to accelerating the anode. Cathode and anode tubes are there in the CRO, that is cathode ray tube, it is there here now. So it is going to accelerate the anodes, and deflection plates are close to ground potential here now. Ground potential means nothing but with respect to ground, how much voltage is there. Based on that, which is close to ground potential, we are going to calculate now. So the ground potential protects the operator from high voltage shocks when making connection to the plates over there. Whatever the ground potential voltage is there, that will protect the, what is that, protest the operator here now, who is going to operate in the instrument, that is which is connecting to the arms, that the patients are connecting to the measuring instruments in the research area. Suppose 200 volt is there, suppose 220 kV voltage, or you want to measure some protection circuit, we have to connect that one. And that situation, someone is going to operate that one. So to protect the operators from the high voltage shocks, we are maintaining the ground potential here now. So when making connection to the plate here now, while doing the connection plates here. So the deflection voltages are measured with respect to ground only. We are considering the ground potential, means with respect to ground only, we have whatever the deflectings are there, we are going to consider here now. Therefore, high voltage blocking or coupling capacitors are not needed here. So to protect here now, if we are using positive high supply, then we have to use the coupling capacitors we have to use. So we are using the low voltage here now. So that is negative supply we are using here now. So no need to use the coupling capacitors here now. For that reason, coupling capacitors are not needed. That is got one advantage here now. But low voltage rating capacitors can be used for the high voltage supply to the vertical and horizontal here now. Low voltage capacitors we are using here now. So less insulation is required between positioning controls and chassis here now. Less insulation क्यों required है? Current is in milliampere, yes?
Yes, sir.
So current is in milliampere means whatever the insulation is required. So insulation is for the opposition of current, flow of current. So current is less, then less insulation is required. For that reason, less insulation is required between the positioning controls of chassis. We are going to call that one. This is the all blocks, 7 blocks we have discussed about that one. Power supply is there, trigger circuit, horizontal amplifier or time-based generator, vertical amplifier, delay line, and CRT. So these things you have remember, and inputs we have given direct input of vertical input, horizontal input, you can tell that one. So we'll go for the next features of CRT here now. So I told the heart of the CRO is CRT only, that is cathode ray tube only. So what are the features of this one we have to discuss here now. We have to discuss that features of CRT here now. So these are the electrostatic CRTs, that is nothing but the cathode ray tubes are available in number of types here now. These CRTs are also available in number of types, and different sizes are available here now. 10 inches, 3 inches, 1 inches, 5 inches. The display here now, based on the display, the variation will be there, or different size to suit individual requirement. What is our requirement? Based on that, we can purchase that one here. So the important features of these tubes are as follows. The first feature is its size only. The size of CRT tube. How much size we want? Suppose 1 inch display we want, 5 inch display we want, like that. We are based on the sizes we have, that is one features here. 1, 2, 3, 4, and up to 7 inches the displays are there here. 1, 2, 3, 4 is not there, directly 5 and 7 inches are there here. So 3 inches display, whatever we are using, is most common for portable instruments. For the small size, that is 3 inches instruments, and all the places we are using over there. That is the commonly used display size. It is nothing but. For example, CRT having a number of 5 GP. 5 GP, that is called 5 indicates that is 5 inches display we are using here. So the first number 5 indicates that it is a 5-inch tube we are going to use. So both round shape we can use, the display will be like this. A rectangular shape display we can use like this here now. Round or rectangular CRTs are found in scopes today. The vertical viewing size is 8 centimeter and horizontal is 10 centimeter. So 8 into 10, the size of that tube we are using here now. This is one feature of the CRT here. Feature of the CRT. Second one is the phosphor. Phosphor means the light we are going to use here now. That is a lamps tube light bolte na hum, tube light ka. What is the exact name of that one? Which material we are going to use in the tube light? CFL का लॉन्ग फॉर्म क्या है? Anyone can you tell me? CFL सुना है ना? Have you heard the name of CFL? CFL लैम्प का नाम सुना है क्या? At least tell yes or no. I'm asking to you people.
Yes, sir.
CFL, that is compact fluorescent lamp. Compact, so uska size hai chota rehte. That size of that CFL will be like this. They are using some 2-3 tubes they are going to use, that is fluorescent tube here now. So they made that lamp. But the tube light, that is called fluorescent lamp we are going to call here. That is fluorescent material we are using inside the lamp here now. So that name came here now, fluorescent lamp. And compact size we have reduced the size up to, that is called CFL we came here. So the screen is, whatever the screen is there, CRT screen is coated with a fluorescent material here now. That is called phosphor material we are going to call it. It is coated with fluorescent material called phosphor here now. This material, what it will do, it determines the color here now, color and persistence of the trace, both of which are indicated by the phosphor here. Persistent and its color is, we can get that one. Suppose आप देखा है x axis किधर तो रहते, हमने इसको knob rotation करके हमने इधर identify कर सकते हैं. We can identify that one. It is there in the panel or not. We can bring that one into here, back here. So we can trace that one, persistent of the trace here. Now for that reason, it is this phosphor or fluorescent material, it is going to help to determine the color and persistence of the trace here. Now the trace color in electrostatic CRT for oscilloscopes are, it may be blue, it may be green and blue-green here now, mix of that one. The white is used in TVs, televisions we are going to use white, and blue-white we are going to use. Orange and yellow are used in the radar system over there. In the radar systems of central government and all the things, we are going to use this yellow, orange, sorry, where it is? Blue, white, orange and yellow are used in the radar over there. So persistence is expressed as short, medium and long here. Now, whatever the persistence of the trace is there, it may be short, medium, long here now. So this refers to the length of the time of the trace here. Now if it is length is very big, so here that is long we are going to call, here medium we are going to call, here it is a short we are going to call that one here. Now based on the time trace we are going to call remains on the screen after the signal has ended over there. So that is the second picture is the material whatever we are going to use, that is phosphor material is the second feature of the CRT here now. So that one only they have told. P1 is green, medium for the We can P2, that is blue green. Mix we are using for the medium persistence. For the short persistence, we are going to use P5, that is called blue, very short. And for only short, that is PL1, we are going to use only blue, we are going to use that one. So color consistency. Next is very important thing is operating voltage. Already I told that one, it is -2 plus we are operating that one here. No, so this is operating voltages are, that is the CRT requires heater voltage for the heating of the voltage 6.3 volts AC or DC at 600 milliampere. You know, current is 600 milliampere. 600 milliampere करो कितना होता है? 0.6 ampere.
Yes, sir.
0.6 ampere current is required. That is less only, na. So several DC voltages are listed below. The voltages vary with type of the tube, which type we are going to use based on that one. So the negative grid control purpose के लिए -14 to -200 volt we are going to use. Positive anode for the focusing anode के लिए -100 to -1100 we are going to use. For accelerating anode 600 to 6000 or 200 to 20,000 voltage. Some cases here now. Regularly, commonly we are going to use this 600 to 6000 volt. For some cases 200 to 20,000 voltage. These are the operating voltages. The deflecting voltages are different here now. So the deflecting voltages, just whatever the beams are there, electronic beams, so deflect into the screen, we are required either AC or DC voltage is required here. We'll deflect the beam here now. So the distance through which the spot moves on the screen is proportional to the DC or peak AC amplitude here. Whatever the distance it is going to through on the spot which on the screen is there, that is proportional to the DC we can call, or whatever the peak value is there. Peak value is nothing but here the waveform is there. Here the waveform is there. Okay. What is the peak value here now? Where is the peak value? Peak value means the maximum value here now. This is the peak value, positive peak and negative peak, we can call that one. For the DC, it is going to show that straight line or some dot, it is going to show that one. This is the proportional to the whatever that is distance, we are going to call that one here, which is the screen proportional to the DC here now, or peak AC amplitude we are going to call here. So the deflection sensitivity of the tube is usually stated as the DC voltage or peak of the AC voltage required for each centimeter of the deflection of the spot screen here. This is going to deflect here. So each centimeter we are going to require whatever the deflection spot on the screen, the supply is required here. That is deflect the signals we are going to deflect on the screen means that is deflecting voltage. So we are going to call for the operation of the CRT, that is operating voltages are required. Next, how we are going to view the screen over there? What is the size of that one? Height, width of that one. Based on that, we have to view the screen here now. The viewing screen is the glass face plate. The front is glass only. Okay. The inside wall of which is coated with phosphor material here now. Again, the phosphor, that is fluorescent material, it is coated here now. The viewing screen is a rectangular screen having graticules. Graticules means all the signals, whatever the gratitude, number of gratitude signals are joined together, that is called graticules. We are going to call that one here. We are connecting the signals like this here. Graticules marked on it. The standard size used nowadays is that is 8 centimeter to 10 centimeter. So that is called 8 centimeter on the vertical and 10 centimeter on the horizontal here now. 10 and upper side, it is 8 centimeter like this. That is from here now. Each centimeter on the graticule corresponds to one division here now. Like this, it is going to give the I think how many of you have seen, I don't know that one. Like this, it is there. The screen में ही ऐसा लाइंस दिखते हैं हमको, दिखते क्या नहीं? देख रहे हैं क्या? कैलकुलेटर, डिजिटल कैलकुलेटर है क्या वो आपके पास? ऐसा just like this, they are going to already the divisions are there here now. So the standard phosphor color used nowadays is blue here now. We are going to use blue only. They are going to use that one here now. These are the features of the CRT here now. Can anyone tell me what are the features of the CRT? Fifth one is viewing screen. Okay, पहला one कौन सा है? size, second one is phosphor material, third one is operating voltage, fourth one is deflecting voltage, fifth one is viewing screen here. So these 5 are the CRT tubes and 7 main blocks of the CRO we have discussed, and maybe tomorrow I will explain about this DSO and its block diagram and how we are going to operate that voltage frequency, how we are going to measure that one. So maybe tomorrow is, I think, working is there. Maybe I don't know if any notice comes, or tomorrow or up to Tuesday finish that one and be ready for the chapter test 5. And remember one thing, be ready for the attend assignment also. I have given already 5 assignments I have given. After completing this 6th unit, I will give the assignment of the 6th assignment also. I will give only 3-4 days time. So you have to submit. I will provide the link. All the assignments separately you keep scan it and keep with you. And for each pages you have to write your roll number and name for assignments. Remember that one.
ओके सर. PDF एक बनवायची का सेपरेट सेपरेट?
नाही, separate. Assignment wise you have to make separate.
ओके सर.
Assignment number 1, 2, 3, 4, 5, 6. 6 assignment you have to write separately. Okay. So we'll stop here only and we'll continue in the next class.